All right, in this video, we are going to be taking a look at quadratic functions. And hopefully when you hear the word quadratic or quadratic functions, you think of a parabola, right? When you're thinking of the graph, you're like, oh yeah, that's a parabola. And this parabola right here, this U shape, could just be the most basic of our quadratic functions. F of x is equal to x squared, where we say that it has its vertex at the origin. So this is its vertex. And in this case, it's at the origin, so it's at 0, 0. All right, so we're going to start off by taking a look at two different forms. All right, these two different forms that we're looking at are standard form and vertex form. So this first one, standard form, this is probably what you're used to when you were trying to factor quadratic equations. Was you had f of x is equal to ax squared plus bx plus c, and then you would factor it, right? You multiply a times c, and then you get some number, and you say, well, what multiplies to that and adds to b, and boom, 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 you factor it, and that helps you to find the zeros of the function, or the x-intercepts of the function. All right, we're now going to take a look at vertex form, and the cool thing with vertex form is that vertex form, well, looking at it, a times x minus h squared plus k, vertex form really relates to transformations, which we were just doing. If we have this basic function, f of x equals x squared, we know its vertex is at 0, 0. Well, down here, what's happening is, well, x minus h, we know that shifts it to the right h, so my vertex x value is going to be h, and then the plus k is going to shift it up k units. So the vertex, whenever it's given to you in vertex form, your vertex is always going to be h comma k. All right, so x minus whatever value squared, and then plus the value on the outside. That is the x value of your vertex and the y value of your vertex. This a right here is actually the same exact a as this function up top. And what we can see here is, well, a tells us what direction the parabola is going to open. Usually, parabolas open up. So if a is positive, it's going to open up. However, so a is positive, or a is greater than 0, opens up. If a is negative, well, think about what happens if we were to change this to f of x is equal to a negative x squared. That reflects it, right? A negative x squared, that reflects it over the x-axis. So reflecting over the x-axis, that is going to make it open down. So when a is greater than 0, it opens up. When a is less than 0, it opens down in vertex form and in standard form. All right, so finding the x-intercepts. And here I've just written a couple of other names for x-intercepts that we're going to be looking at throughout Chapter 2. Those are also known as the zeros of the function and the roots of the function. All right, we're finding the x-intercepts. We're looking for the zeros and the roots. And whenever we look for the x-intercepts, that's when y is equal to 0, or when f of x is equal to 0. So really the two main ways of doing it are we can factor, or we could do the quadratic formula. All right, and then sometimes when it's given to us in vertex form, we can just solve. Okay, we can solve almost using the method that we used when we would complete the square. All right, so here let's find the x-intercepts of each. This first one, f of x is equal to x squared minus 6x minus 16. Well, I factor that. I set it equal to 0. X minus 8 times x plus 2 is equal to 0. So I get x equals 8 and negative 2. All right, those are my x-intercepts, are 8 and negative 2. For this next one, you kind of have two, you really have different options. We set it equal to 0. We need to set it equal to 0 because that's what we're wondering. Okay, we'll add the 12 over. 12 equals 3 times x minus 1 squared. Divide by 3, right? We're trying to solve for x. Divide by 3, that gives us 4 equals x minus 1 squared. Now we can take the square root of each side. Well, square root of 4 is positive or negative 2, right? Remember, we are the ones initiating the square root. And so we have plus or minus 2 equals x minus 1. So then 1 plus or minus 2 equals x. Well, our x-intercepts are going to be 1 plus 2 is 3. and 1 minus 2 is negative 1. So those are my x-intercepts for that one. For this one, let's see, I'll try to do some AC factoring. Multiply 2 times 6, that gives me 12. So what multiplies to 12 and adds to negative 4? Nothing that I can think of, right? And don't try and kill yourself. Don't think too hard. All right, let's just jump straight into the quadratic formula and see if that works for us. So x is equal to negative b, right? Negative b is 4 plus or minus the square root of 16 b squared minus 4ac. 4 times 2 times 6 all over 2a, which is 4. All right, I'm going to have to clear out some of this stuff right here. Get this out of my way. And that's 4 plus or minus the square root of 16 minus 48. 16 minus 48 all over 4. So I get 4 plus or minus the square root of negative 32. Uh-oh, square root of a negative. Oh, that's not a real number. Well, if that's not a real number, we're not going to have an x-intercept there, right? You can't have an x-intercept at an imaginary number or a complex number. That doesn't really make sense because we can't see those on a graph. All right, so this one is not going to have any x-intercepts because it doesn't have any real zeros. It doesn't have any real roots. When we do the quadratic formula and try to solve for when it's equal to 0, we get a complex number. We get two complex numbers. So this does not have any x-intercepts. Let's just graph this and double check that. 2x squared minus 4x plus 6. We have, screen's flipping on me. 2x squared minus 4x plus 6. And we can see, yes, because its vertex is up here. Its vertex is at 1, 4, and then it opens up. Well, it's never going to drop down low enough to cross over the x-axis. All right, so, yep, no x-intercepts for that last one, unfortunately. All right, now let's take a look at vertex form. So vertex form, we know that our vertex occurs at h comma k. All right, and if we remember back to these even functions, if I had a parabola whose vertex lies on the y-axis, we would say that, oh, it's symmetric with respect to the y-axis. Well, every parabola is symmetric over some axis of symmetry, right? I could draw a line where if I were to fold the parabola over that line, it would land right on top of itself, right? It looks the same on each side of this axis, right? Right here, boom, well, reflected over, oh, it's at the same exact point. And this axis, or this line that I drew, is known as the axis of symmetry. Well, it's a vertical line, so it has the equation x equals, and I know that the x value just needs to be equal to the x value of the vertex. So the axis of symmetry has the equation x equals h. It's just x equals whatever the x value of the vertex is. So let's practice just finding the vertex with some functions. All right, let's identify the vertex of f of x equals negative 3, x plus 2 squared plus 4. Well, this is left 2 up 4, so negative 2 comma 4 is our vertex. And then we can see that it's going to open down, okay? It's going to open down. So we could actually even find the zeros of this function if we wanted to. We could find the x-intercepts. They are going to exist because this graph starts right here and then opens down. Let's just take a look at this graph quickly. Negative 3, x plus 2 squared plus 4. All right, negative 3, x plus 2 squared plus 4. And boom, there is the graph of that with our vertex at negative 2, 4 there, which we can clearly see. All right, let's identify the vertex of g of x equals x squared minus 6x plus 11. Well, this is not given to us in vertex form. This is standard form. How in the world am I going to find the vertex? Well, it's coming back, boys. It is coming back. We need to complete the square. Complete the square. All right, we want to make this a perfect square, okay? And remember how we do that. We take the b value and we divide it by 2. So divide b by 2. Then we square it, and then we add it. All right, let's just practice this. Hopefully this is a brief review of completing the square. So we take x squared minus 6x, and I always like to write that in parentheses to start, just so I can look at, well, where am I trying to complete the square? So that's x squared minus 6x. Well, what do we need to add in order to complete the square? We divide the b value, negative 6, divide it by 2, that's negative 3. Square it is 9, and then we add it. All right, perfect. We add 9. Now this is just going to be a nice x minus 3 squared, right? That's x minus 3 squared. You FOIL that out, you should get x squared minus 6x plus 9. Well, the one step, we're not allowed to just add 9 to the function right here, okay? Right? I can't just say, I'm just going to add 9 to the right side. That works. I'll just add 9. We need to balance that. We need to counteract that by subtracting by 9 from the outside. So if I'm going to add by 9, you then need to subtract by 9. Well, 11 minus 9 gives us 2. So this should have a vertex of 3, 2. And then the axis of symmetry, our axis of symmetry would be x equals 3. Let's just graph this, x squared minus 6x plus 11. X squared minus 6x plus 11. X squared minus 6x plus 11. And if we click on this, 3, 2, that is our vertex, and it opens up. And then our axis of symmetry would be x equals 3. Let's just graph that. And we can see, yep, appears to cut that right down the center. Nice. All right, let's finish it out. Let's do one more example with completing the square. This one's a little bit tougher, but we could do it. F of x is equal to negative 2x squared plus 6x plus 4. Well, I'm going to start by drawing negative 2x squared plus 6x. I'm just putting parentheses around those first two. Well, I want to factor out a negative 2. I do not want this x to have any value attached to it. So let's factor out a negative 2. Negative 2, and then we have x squared minus 3x plus 4. Now to complete the square, we're going to divide by 2, square it, and then add. So negative 3 divided by 2 is negative 3 halves. And negative 3 halves squared is going to give us a positive 9/4. So that's what we'll be adding. Negative 2 x squared minus 3x plus 9/4 plus 4. And then we remember, well, whatever we add by on the inside of the parentheses, we need to subtract by. So then minus 9/4. However, we did not actually add by just 9/4 here. Because we have this negative 2 out front, we really added by a negative 18/4, or negative 9 halves, right? You have to multiply negative 2 times that 9/4, which is a negative 9 halves. So really what I added was I added a negative 9 halves, which means I need to add a positive 9 halves to the outside. So I'm not subtracting 9/4 here. I'm actually going to add 9 halves. All right, I add 9 halves to the outside because, yes, I added by 9/4 here, but I actually added by 9/4 times negative 2, which is the same thing as negative 9 halves. So to counteract that, I added positive 9 halves to the outside. Now this is going to be negative 2x minus 3 halves, right? You're taking that b divided by 2 value, minus 3 halves squared, and then plus, well, 4 is 8 halves, so that's plus 17 halves. And then my vertex, I'm putting this up here now, okay, my vertex is going to be 3 halves, comma, 17 halves. And that's the same thing as 1.5, comma, 8.5. All right, 1.5, comma, 8.5. Let's just graph f of x and see what happens. And again, this is going to be opening down because my a value is negative. Negative 2x squared plus 6x plus 4. All right, let's give that a shot. Negative 2x squared plus 6x plus 4. And we check that out, 1.5 comma 8.5. And that's exactly what we had for the vertex. And of course, our axis of symmetry would be x equals 1.5. That's going to cut it right down the middle. All right, best of luck on the homework. Hope that this helped you guys out and was kind of a refresher on completing the square and factoring.